Hello there. Welcome to the Healthy Enterprise Podcast. Thank you for joining me again. If you're back for more, I appreciate your return visit. And if it's your first time, I hope you enjoy this episode. I'm going to be speaking with Georg Draude. He is the General Manager of Chroma Technology, where he leads the company's European operations and strategy with a background in biomedical sciences and over a decade at Chroma. He's played a key role in advancing the company's work in optical filters and imaging solutions. Georg is very passionate about bridging science and industry and fostering collaborations with researchers worldwide. It's going to be an interesting chat, so I'd like you to meet Georg Draude. Let's get started. Georg, hello, welcome to this episode. Thank you so much for joining me today. I'm looking forward to our conversation.
Thank you for having me.
So why don't you start with doing an introduction of yourself and the company?
Well, I start with myself. So my name is Georg Draude. The German pronunciation is more like Georg Draude. And
Are you going to make me try that?
no, you don't need to. It took me 50 years of my life to understand that my family name, if I pronounce it French, everybody understands it. If I pronounce it German, nobody understands it.
Oh, is that right?
So many years ago, I made my PhD in the Biomedical Institute and left academia in the early 2000 years and worked a couple of years as a sales field engineer for microscopy imaging and different laser applications, which was more industrial. And joined in 2010 Chroma Technology, and working since then for the company in the European branch office, overseeing sales for Europe, Middle East, India, and some other selected areas. Chroma Technology itself was founded in 1991. And the sixth founder had two visions. The vision number one was producing optical filters for the microscopy application of fluorescence proteins, which was a very novel technology to image intracellular structures. And the vision number two was to create a good workplace. So they started the company as an employee-owned company, which is still our structure these days.
Oh, interesting.
So
Yeah.
Chroma has around about 180 employees. We have our own engineering subsidiary that is more looking for light sources for the biomedical market. Chroma itself is very focused on optical filters for biomedical. So these days it's 50% or more biomedical research and diagnostics. We do some machine vision, we do some other industry like automotive, defense. And the first 10 to 20 years was very focused on fluorescence microscopy.
Very interesting. And I mean, for people that aren't as familiar with Chroma technology, I mean, we're really talking about the managing and manipulation of light. That's a kind of a simplified way of
Absolutely. If
looking
somebody
at it, right?
asks me what are you doing, I normally say first thing we are producing optical filters, or we're producing filters, and people think about filtering air or filtering water, and then I have to explain, no, we are filtering light, and the main thing is to manage light in an instrument, to get the light to the right point and get the light back to a detection system. That's what we are doing.
Right, and it's using the color of light as well, that as kind of a part of that to help.
Yeah, I mean, we always think in wavelengths, not so much in colors. I know that you come more
Right,
from the photography, which is more color. We are
right.
always talking about wavelength, but at the end of the day, clearly it's the color. And one of our side markets, I would say, is astronomy. So we are producing filters for the astronomy community, which is not really an industrial market niche. It's more hobbyists that looking into the sky, and they need the right filters to filter out all these nebulas. I don't know exactly how it works, but we get the nicest images back from this community, and this is always um, colored with an artificial color hue, but it looks pretty nice if you see this nebulas that are millions of light years away. And so yeah, we do lot of things with color and trying to manage light.
So in the biotech world or biodiagnostics, what is it what problems are you resolving? Like what is it that was identified as like, oh, we need to resolve this or fix this or make this improve on this? How are you making those improvements?
If you think about the first years, which I mentioned that this was the one vision, in an early 1990s, you couldn't get specific bandpass filters that just cut off a small portion of the light that is needed to very precisely excite these fluorescence proteins, and then on the other side of the experiment to image the emission of the fluorescence. Um, so at that time, there was no technology that allows the researchers to get this done in a proper way, because microscopy companies used mainly colored glass or absorption glass that could deliver a long pass or a short pass cut, but not a small band of light to cut out and block the other light that should be detected by the camera. And so this led us to understanding of our business, that we work very closely with the researchers that ask us to develop the filters they need to get their experiment done. And in this tradition, we are still in very close contact to our customers. These days, it's not only the researchers in the universities and medical areas, it's more and more also people starting a spin-off company in a research incubator that have the ideas and contacting us and say, we are working on a new instrument. Let's throw in a keyword, POCT, point of care technology. So
Oh,
small
okay.
handheld instruments that make a testing for whatever, urine or blood, to identify a disease or an infection. And these people come to us and say, hey, we need a specific filter set that helps us to get this small application in our instrument working. And yeah, so that's the way we still understand our business. So we don't understand us the way like being a catalog company where you can select from a catalog and say, okay, I need this red filter, I need this green filter, and that's it. So
It's very
we listen to the
very
customer and trying to develop new cool stuff together with them.
so, and these are very niche, like they're very specific and focused on what they're looking to resolve. They've got their own problem they're trying to fix, and they're coming to you and saying, "This is exactly what we're looking for, and what we need to be able to do is see it in a very specific way." And then you're coming up with a lens or a filter that will allow them to see what they're actually looking for clearer and more specific, right?
Exactly. I mean, we have a
Okay.
pretty big database, being in this market for more than 30 years.
Yeah.
But we also changed technology. So the technology we started coating with in the 1990s retired in the early 2010 years. So this database has to be renewed over and over again. But if we don't find in our database what these developers are looking for, then we always are open to say, okay, let's have a new filter design. So we have a group of, we call it um, filter designers. So it's really a design work what they do, and the magic I don't understand because I'm not an engineer and I'm not
Right.
um, totally into the technology, but they do the design, and you see a filter curve like here's the transmission, there's the wavelength, and this is the filter curve. And then the magic is that they transist this curve into the coating machine. And at the end of the day, you get the filter exactly with this curve.
So interesting. I mean, I keep bringing it back to my being a trained photographer and understanding that, we use lenses as photographers and we apply filters. And I'm talking about old school, not filters on your app on your phone, but filters we would actually screw onto the ends of our lenses. And they would be for a variety of things. They would warm things up or cool things down or block light or let more light in or polarized light, or there's also infrared, and so there's so many different filters you can get for your camera. So I keep thinking of it from my perspective that was how I can relate to it, but it's not that different, is it?
Well, it's pretty much what I described with when we started. At that time, the filter you described was what was available on the market. So a filter that cuts the red, or a filter that cuts the blue, or a filter that let infrared through. And now we putting the wavelengths, the visible wavelengths from, let's say, UV up to near infrared into portions customer needed, wanted.
So interesting. And you've probably seen such a transition in the industry, in the time that you've been there. So many changes have happened in technology, and so talk about that a little bit. What have you seen, and where, you've started with where you have come from, and
Well,
what a
you think
growth you've
about if you
experienced.
think about microscopy, so when I started in this industry, um, it was mainly from the detection side, cameras like you would use in normal life, like cameras with a film that was
Yeah.
attached to the microscope. And I was working for a company that was selling digital cameras to these customers, and there was nobody else. So, and this was not a fast camera like you have now with a digital camera, always has a live image. No, this camera has a shutter like the old film camera, and it makes
Yeah.
one image after the other. And the tricky part was to align the camera to the focal plane of the microscope. If you get this problem solved, then you get nice images, and boom, the camera is sold. If you look at the microscopy world these days, um, CMOS was a big push in the microscopy for high sensitive cameras, which was never seen before. So that means the researchers can go with very low exposure times, having what they call live cell imaging. So you can really see live a cell moving, or an nucleus and a cell moving, and uh, proteins are attacking to the cell. Things you have never be able to see in the early
Hmm.
1990s and early 2000s, and the resolution is um, expanding. So now you have a bigger field of view. This means the microscope companies needs bigger filters. We have to think about a different angular tolerance because the field of view is bigger. All these challenges, and the very interesting development I saw in the last, let's say, 2 3 years is that it also goes not only into the smaller scale. So I think everybody heard about the Nobel Prize that was given to the people inventing the technology of super resolution. So super
Hmm.
resolution means that you get below the 200 nanometer that AB was calculating in the 19th century as the limit of visible light in a light microscope. And there was a big hype. Everybody who could have afforded bought a super resolution microscope, which is 500,000 to $1 million. And these days, you see that it goes right in the other direction. Researchers want to see the whole image. They want to see the whole picture. So they have a living tissue, and they want to see where the genome, where the DNA, where the protein is in the tissue. And this is a big challenge because you have a big piece of a specimen, and then you look into it and get in a 3D information where the disease is induced, or where the protein is blocked, or where the protein is stocking on, and all this um, um, very important research about how diseases develop and how diseases can be treated.
Wow, it's very my mind's kind of getting blown a little bit right now
Yeah,
because
sorry, I'm talking a bit too much.
I'm thinking about you're on one end of the spectrum. You're living, you're working in the microscopic world where you're getting finer and finer, more detail, more depth into the more microscopic world where you're seeing things, and I'm sure light is behaving differently in that space, and you're manipulating the wavelengths. The smaller things get, right, and it's infinite. I don't think we know how small life actually gets, do we? And then on the other spectrum, you're actually going, using telescopes to look into space, and again on the other spectrum, you're going further and further away into a larger and larger area of space, and where light is also very different in the wavelength, and you're helping to basically allow people to see in those two worlds in a time
Yeah,
where they couldn't be able to do that.
that's a good point. In fact, we are also having some customers in the market we call space communication. So this is a
Oh,
big thing. Um, so we have all the satellites going around the globe, and it's kind of pest that if you ask me, I think it's too many. Um,
right.
and the communication so far is radio based, and now they are working more and more on laser based communication on an
Oh,
infrared wavelength, because you can go with a very thin um,
beam.
part of the spectrum. If you think about the whole spectrum of waves, so starting with X-ray and going to radio, and radio is very wide, and if you go on an infrared laser, it's
Oh, okay,
very
it's
narrow.
very narrow. Okay.
So this has many advantages. It's less noisy, it could be less disturbed, and so this is what they are working on, and this needs very high quality material because it has to go into space.
Wow. Very cool. Like it's just so, and it's infinite because we don't really know how far into the micro world we can go, or how far away from into the universe we can go. So that's very interesting. You're in space exploration at the same time as
And going
being in
into
the microscopic world.
in the proteins,
Incredible.
yeah.
That's very cool. So what, when you were, younger, what drew you to Chroma? What was it about this company that attracted you at the time when you before you came to them?
This is a very private story, but it's I would um, title it with "It's all about your network." So I started studying biology in a very classical way. So I was counting flowers, and I was um, um, taking snails and put them in pod, and all what microscopists or what biologists are doing. And then had a chance for a PhD position here in Munich, and worked on receptor expression on blood cells, and just had enough from science and want to make some money, and was looking for a position in industry, and this led me to this microscopy imaging. And I start working on my network. And one day, one former colleague from my PhD lab, she contacted me and said, "Hey, um, I have a job offer," and that's how I get to Chroma.
Huh, so cool. And how was that transition from you from going from science to management?
That's a very interesting question, and I've been on a panel discussion recently at the Laser World of Photonics show here in Munich, and people were asking how can we get the right people from academia to industry. And I
Hmm.
think it's a big shock um,
That's a good way to
for
put it.
for those who leave science because they have this very high academic approach, and now they work for a company and has to sell stuff. So that's kind of they are useless for the science community, and former colleagues let them also fear. And I think that you need to find the people who are really burning for doing something, and finding out that selling a microscope or selling an whatever blood analyzer is also a very complex technology, and something that needs to be explained to the users, and there's nothing wrong with it. You see sometimes people they um, come from academia into industry and never understand that they are no longer in academia, and they used to do their work the same way. So they always want to finish a PhD thesis instead of,
Hmm.
hey, at the end of the month I have to sell this bloody instrument, and if there are something is not perfect with this instrument, so what? It has to be so. This is how business is going, and this is
Exactly.
what
Yeah.
you have to teach the young people that hey, yeah, you are in a different world now, but I always say that when I was working on my PhD, I was only looking, and we are again on big and small scale, I was just looking on one single thing, expression of one receptor on one monocytic blood cell. The years after, when I was selling microscopy systems, I saw all the different disciplines of medicine and biology with my customers, and this was very exciting. So I
Hmm.
remember one thing that was the most exciting thing. An institute in Berlin, they did tick research. You know, the small things
Oh,
that goes
yep.
into your skin.
Yeah.
And I came with an confocal microscope setup that I want to sell them, and we made crazy cool images of this tick. So you see all this mandibles and the arms, and they look like monsters
Yeah.
and
Aliens. Yeah.
amazing.
Well, they've spread crazy disease too, and so it's an important area of study because there's some devastating disease that come from that from ticks. Yeah.
Absolutely, yeah. I mean, I was just in New England area in June, and they have a really hard time with ticks in this week. So ticks everywhere.
Yeah. Yeah. um, we were talking about your. So I mean, when you go from, I liked how you put that. You went from being a scientist to really selling science. And I mean, when you think about it, what better way? Who better to sell something that's very scientific than someone who understands science? At the same time, is there a when you're trying to communicate, when you're selling a product or selling a concept, can it be over scientific as opposed to being more layman or more understandable by the average person? I mean, scientist to scientist, you guys like talking science, but how do you transmit that or translate your messaging to a broader audience?
Oh, I think that's for me it's an easy task. I know that, and this is exactly the person I'm talking about. I know that there are people in the industry that are always trying to impress the people they're talking with. what they know and how smart they are. That's not the way you are going to sell your instrument in the industry. You have to
Right.
listen to your to the people you're talking with and use their language.
And so, what did you discover about yourself when you went into this new world of management and selling of science? What did you discover about yourself as far as your characteristics or your skills that really lent well to this new role?
I think it's pretty much communication. You have to be good in. So you have to listen, and but you also have to give the right answers, and you also it's always okay not to have the full answer. I mean, you are the front person in the relation between an industrial company and the customer, and you have your engineers in your facility, and you don't need to know everything, but you can write down the question and say, okay, I'm coming back to this. That's an interesting question. I don't have the answer right now, but um, I don't need to have the right answer. I have my engineers, so
Right. You have a whole team behind you to
right.
help answer that question, right?
Yeah, and it happens more and more since we are so used to have conference calls that if you're going deeper into the detail, then you arrange a conference call where you call in your engineer from overseas, from the US, and the most tricky part here is to match time zones. So if you have a customer in India or you have a customer in Malaysia, and then you want to have a conf call with these people and the engineers from the East Coast, it's manageable. If you have somebody on the West Coast, it doesn't matter anymore. It doesn't work anymore.
No, no, yeah. And did you find going from being scientists are typically work very solo, whereas now then you went into a world where you had to work with a lot of people, work with teams. How was that transition for you?
I wouldn't say that as a good scientist, you always work with a team. You have your
Oh, okay.
institute, you have your peers. There's a kind of competition between especially if you think about being a PhD candidate, then you are 5 to 10, and you have to give a report about where you are with your research in a weekly meeting. So I think researchers are not lonely people in a tower working on their own product. They are more and more working in a team.
They're working on a team. And as far as leadership, moving into management, now you're a leader. You're leading a team. And how do you develop your leadership skills and maintain those? Do you work with a coach or anything like that, or what do you do to kind of keep yourself up to speed with leadership?
I don't want to say anything bad on coaches, and we recently had a sales training with a professional a coach. Um, I just try to be, let's say, the one that makes life easy and happy for my team, finding out what they need. Um,
Hmm.
what they need for equipment is the first thing, what they need for work-life balance, and then just take them on the hand and go together with them in meetings and encourage them to lead the meeting. That's important.
Hmm. Hmm. Looking ahead, what kind of challenges are you seeing for the company? Challenges or opportunities? What do you see for the future in the coming
I
years?
mean, the opportunities are there, and it's clearly going in two different directions. So the one is going into a smaller scale miniaturization. I mentioned point of care technologies, or
Yeah.
what used to be a lab of instruments with lasers, microscopes, cameras. can be in 10 years a benchtop device where a medical doctor somewhere in Africa or India can do the quick test on site. That's the
Right.
one thing. The other thing with what I mentioned is that we go on the bigger scale, that cameras are getting more sensitive, having a better resolution, which allows the manufacturer to grow the field of view. That's the other direction. So we go into small size, we go into bigger sizes.
Mm-hmm.
Um, what we face this year is very obvious. So we see that the domestic US research market is very confused. There's a huge uncertainty where are still there. Um, um, and then thinking about the global market, I don't believe that tariffs are helping a global market. And if you want to grow globally, then you should. A trade war doesn't help. Let's say it this way.
Mm-hmm. Yeah. Well said.
But I
Well
mean,
said.
this also pushes us to think a bit more about collaborations.
Mm-hmm.
So don't understand the competition from Asia as competition only. Also think about can't they be a collaborator? Can't we do something for them and do they do something for us? So
Mm-hmm.
it also induces some creativity. So
Yeah.
you just have to be smarter than some others.
Yeah, it pushes you to look at opportunities you may not have considered before, and it could be, it could be a lot
And
of
what
positive
really
outcomes.
helps is if you are in a more academic market, it's ways easier that people don't make a distinction about religion, about passport, about skin
Mm-hmm.
color. They
Mm-hmm.
collaborate.
Yeah, I've heard that. I've heard that a lot, actually. Yeah.
So I don't know if
Um,
we have time. I have a very emotional story. So we give out a research prize to a young researcher at a conference on human diseases that happens every year in Europe and then moving back to the US. And since a couple of years, I have the honor to hand out the research prize. And, and this year, a young researcher from the Weizmann Institute in Israel was selected, but she couldn't come because it was right in the week when there was this big bombing from Israel to Iran. And her lab was burned down by an Iran missile. And
oh
she
my
gave a
gosh.
very emotional speech. And the content was really what I mentioned, that she's not involved with anybody, and she doesn't have any enemies, and she believes on working together globally, no matter what citizenship or religion or skin color. And,
Wow,
and, then and the speech was broadcasted into the lecture hall because she couldn't come.
she couldn't attend,
Yeah.
and she was limited. And then she's starting from scratch again now because she doesn't have
Absolutely,
anything.
but she's saying this is not the big thing. So she get help offered from everywhere. You can come and work in our lab. She said the most
Wow.
sad part of the story was that she had samples from a former coworker who suffered a very rare cancer, and this coworker died, and she had samples from him to work on, and these samples
Are gone.
got destroyed.
Wow. Wow. Very sad. Very emotional story. Yeah, that must have been something to hear in live for sure. Um, what are you? How are you adopting AI into the company? Are you working with it, applying it in other ways, or how are you using AI?
I'm pretty skeptical, I have to say. Maybe that's because I'm an old guy. Um, I think AI can be very helpful. If you think about, we have a huge database on filter designs. I would like to say, AI, find me a filter with this center wavelengths and this blocking range, and boom, here it is. Great.
Right.
I don't like people asking AI, tell me about the business in India in microscopy for the last 3 months. You get a result, clearly, but can you rely on it? Is there any evidence that what is spitting out is true? I don't know.
I think that's a really good point. It's something that AI is a great tool, like you said. It can help streamline and speed up mundane tasks, but it still needs a human operator. It needs a validator, somebody who's going to say, yeah, that's actually quite accurate. It's great to be able to collect a whole bunch of information, but it still has to be
Yeah.
proven. You're
Or,
right. It's
another example, which is really, I think this is a good field for AI. If you go back to microscopy, because of this, what I said, the cameras are getting faster, they have a higher resolution. One experiment can be easily 2 terabytes. And now the researcher has to look at 3 hours of recording to find out the very important image that proves whatever concept. And if AI can help and say, use this, build a software AI base to go through this 2 terabyte of camera records and find out what I'm really looking for, I think this is a perfect solution where AI can help
Yeah, I
quite very
think you're right. I
fast.
think there's a place there for AI. Probably a place for AI everywhere. It's just finding out exactly what's it going to do
Yeah, and
best
I think the
for.
humans should control it and set the limits.
Yeah, yeah, I would agree with that for sure.
It's
Right
like
on.
growing a puppy. You also have to control it and set limits.
Yeah, yeah, you have to guide it,
Yeah,
right? You have to guide. Well, they always say when you're taking uh, dog training lessons, you're actually taking dog owner lessons.
right. And if you talk to an old veterinary doctor, they say it's all about the owner's treatment.
That's right. I think that's right. Exactly. So taking ownership, I think, is the key.
Yeah.
Is the message there? Taking ownership of your AI and not letting it run free and uncontrolled for sure. Yeah, that's a good point. Um, hey, is there anything about Chroma we didn't discuss that you'd like to make sure we mention today?
I think we made a good way from when we started it, how we started it, and how it is now. I mean, what may be important to say is that being in the market for more than 30 years, we have a really good brand awareness and a good reputation in the global market. And we are very proud of it. And especially, we are proud being independent. So all of our competitors have been merged or acquired 1 or 2 times, and we are still the, from the global scale, one of the big coating houses that are still independent.
And I know we were focused, a lot on biotech and biodiagnostics and microscopy, but there's a lot of areas we kind of just scratched the surface. You're involved in a lot of different industries. So, if people want to, where's the place people can go? What's your website where people can look at and see more about what Chroma is doing in the world?
I mean, that's what we are working on. The website shows the different industries. It's not so easy to show everything, and from the history, it's still focused on microscopy. But we always encourage people to just grab the phone or fire out an email and ask a question about things they could not find on the website.
Great. And then people can find you on LinkedIn as well if they want
Yeah.
to connect and get more information. Well, George, this has been really interesting. I really like talking to you and learning about Chroma and finding more about this very interesting technology that you're working with, and the worlds in which you spend time are really fascinating. So, thanks very much for the time you've spent with me today.
Hey, again, thank you for having me. And yeah, it was a pleasure.
Well, what a great episode. Thanks for joining me on this insightful journey into the world of chroma technology. We explored some fascinating science about light manipulation and learned about the innovative solutions that chroma provides across biomedical research and imaging technology. Special thanks to Georg Draude for sharing his expertise and stories with me today and reflecting on our conversation. And I'm really struck about how chroma's work really connects the smallest cellular details to the big picture of discovery. And amazing to see the principles of light can open such doors to an understanding of life at its most intricate level and drive innovation across so many industries. Is really cool to learn about. If you want to learn more about Chroma, visit their website, chroma.com, or connect with Georg on LinkedIn. I'm sure he'd be happy to have a chat. So please subscribe, share this episode with someone you think it might be interesting to, and until next time, thanks for joining us.